Hi guys, I'm Ryo Ichikawa from Japan. So actually, I can talk Japanese here, but for purpose future, I will talk. I will use English in this talk. So I'd like to give you a brief introduction myself. Uh, I'm Ichi. This is screen name. Captain of Tokyo Western CTF team, mainly working on web and forensic staff. So we Tokyo Westerns also organizer of two CTFs, Tokyo Western CTF and Codeable CTF. As you can see, Codeable CTF is in this conference. Codeable CTF employ non-standard CTF formats called Bullseye. In Bullseye, we evaluate accuracy of submitted exploits, and the exploit with higher accuracy will get higher points. Actually, this topic is not related about this talk. This just introduction. And I developed core engine of Bullseye system. You know, Codeable CTF is now running on contest venue. That's why I'm super tired. I just moved from contest areas, so visit us if you're interested in. Okay, and also Tokyo Western CTF is held by Tokyo Westerns. I authored some challenges in Tokyo Western CTF and maintained infrastructure for the CTF. And Tokyo Western CTF is pre-qualifying event for Codable CTF, and Codable CTF is also pre-qualifying event for DEFCON CTF finals next year. Okay, so before getting into my talk, I'd like to ask you if we can point out the vulnerability in this code. So I think no one can point out. This code saves structured data, just putting secret bearing user controllable data. Looks a bit secure, but actually, this code is vulnerable in some points. Of course, you cannot get the shell in this code unless some zero-day exists in Golang. But how about data raking? Like side channel attack? This picture is power analysis. Is about power analysis. Of course, I will not talk about power analysis attack. Everything will be done in software land. So what was side channel attack? Ordinary exploits like RCE and path traversal will achieve attack directly. But side channel attack completely indirect. It reads sensitive data from side effects. For examples, Spectre abuse CPU's out of order execution for increasing speed for execution. For example, and Spectre uses cache timing, and there are no permission checking for others when out of order execution performed in Spectre. Also, cross-site search. This uses unprotected attributes of JavaScript, and padding oracle. This is in crypto context. Padding error tells plain text. So basically, they're recovering information from side effects. So what is the target of side channel attack? For CPU, Spectre, Meltdown, and some content auditor like cross-site scripting auditor in Google Chrome. In crypto, padding, Oracle, yeah, some side channel attack are there. Also hardware there, but I will not talk about it. So about content auditors. So content auditor means protect users from some malicious attempt. For example, cross-site scripting auditor blocks reflected access payloads from attackers. And WAF, a web application firewall, will block from attackers' malicious requests. Also antivirus software as well. So content auditors know the content to be audited because they should check the content. Content auditors sometimes have evaluation system like a script evaluation system. So side channel attack against content auditor uh, is interesting. For example, cross-site search is triggering false positive for cross-site scripting auditor in Chrome. For brief introduction for cross-site search using cross-access auditor, reflected accesses will be detected and blocked. This is a feature of cross-site scripting auditor, and the attack abuses this behavior. Like, yeah, cross-site scripting auditor will block if same contents in query parameters included in the response body, like script bar secret 1234 is included in response body. So you can iterate every values, and if content auditor fired, you can find that the response body contains this value. So let's call this kind of attack auditor-based Oracle. So how about antivirus software? So antivirus technologies is one of the most common software we use today, like Avast, ESET, Kaspersky, security, blah, blah, blah. And basically, antivirus software protects users from malicious attempts by auditing file contents, network traffic, something. So let's think about this. Auditing data secrets combined with user input. In this context, user input means just controllable data like username, email, and so on. Sometimes this case happens like database stores every information in single file. So in this case, other users' information will be secret. Audit means just checking the content of file like antivirus. So what if attacker could control auditing data partially, like this one? If antivirus audit data including user input, attacker can trigger false positive intentionally. So just checking data combines secret with user input and auditor fired or not, attacker may leak secret by changing user input. Like alternating user input partially, sometimes combined string can be regarded as malicious content. So antivirus can be an oracle in this case, since antivirus has various analyzers for various contents. Basically, antivirus software is totally black box. We don't know when they work, when they will do, how they detect malware. Yeah. One of the most common antivirus software we use today is Windows Defender. Windows Defender is installed on Windows operating system by default, which is the most popular operating system. So let's dig more into Windows Defender. So in Windows Defender, what content will be detected as malicious? Of course, they have their own malware lists and they made it public. But probably other vendors have similar ones but no details published. So we need to analyze it by manual Windows Defender. So black box Windows Defender analysis. After some tries, they running audit process on file access, command execution, and if they detected malicious, block access from user and notify to user. And there are analyzers for various contents, like encoding base64, archive compressions, and executables as well. So black box analyzing is super tiresome work. So, okay. Here, I'd like to show you a demonstration how Windows Defender will detect detect contents. Okay. So here, Windows. So this is Acre. This is called Acre. Acre is signature to test some antivirus software. Basically, this signature totally not malicious, and just for signature. Okay, let's start. And okay, I just saved this signature into acre.txt, and when I try to read them, the window defender get angry that because there is acre signature which is detected as malicious. So okay, yeah, this takes a little bit long time, so just back to slides. So as you can see, analyzing Windows Defender is really tiresome work. So how to analyze Windows Defender efficiently? Yeah, it's really painful work. So this is one solution that mpcmd run.exe directory. It triggers the antivirus engine directory, but still some issues are there. There are unexpected behavior of Windows Defender, like a timing issue and a neutralization, and we have to regenerate payrolls bunch of times. Of course, no debug information, so it's really hard to know why one is detected or not detected. So I try to find any useful tools, and there are good news. Actually, Windows Defender is ported to Linux. This is Tavis Omandi from Google Project Zero, ported to Windows Defender engine to Linux. Actually, they're emulating mpengine.dll, which is core engine of Windows Defender execution. And it enables us to do try and error and show us some useful debug output, like this one. You can see that base 64 is decoded, and the decoded one is also detected as acre signature, right? So there are some tips about this tool. Actually, you can get PDB symbols file in older version uh, from this research. You can get PDB symbols for some version of Windows Defender, which is mpam-fe.exe, which is an archive of everything, Windows core engine and signature files. And you can extract mpengine.dll with cab extract command, cabinet. This is cabinet archive. And also debug features can be enabled by adding debug flag, and it enables us to trace API calls inside. So let's talk about Windows Defender internals. So Windows Defender signature format is .vdm. It's a little bit weird. It's somehow encrypted. But basically, this is just signature for Windows Defender. And in this case, WD extract, which is a useful tool to extract VDM file, will be helpful. So let's see the contents decrypted. So this is just part of a decrypted VDM file. You can see interesting. So Windows Defender uses Lua. Lua is you use some hardware stuff. I don't know, but yeah, basically Windows Defender uses custom Lua bytecode here. You can see some function symbols, MP API, blah blah blah. And finally, I found that there are signature name and signature definitions here. I introduced you Acre signature. This is the upper part is just Acre test file. This is a name of Windows Defender, and the bottom one is Acres and Antivirus blah blah blah. This is string that I showed you before. And also I found some handlers for various file formats. So for example, mpcrypt, I don't know about this format. LZMA, this is really well-known format. And XZ, ZZip, LZ4, something. Yeah, so many formats. So just after white box analysis, actually this is not white box. I found Windows Defender has JScript analyzer with DOM API supported. And not just parsing, they're just also emulating. So if JScript calls evaluation, the argument of eval function will be also audited. So basically, if you evaluated Acre signature as eval function's argument, it will be detected. So what happens if combined them? So here is attack to demo applications. This is just simple application for POC. This application is not real world application. So basically, this application stores controllable area 1 and controllable area 2, which will be given by get parameter of HTTP request. They will save data with this format. Of course, user cannot see this secret. And there is another API to check existence of this structure of data and integrity. So under this condition, how to leak the secret? So let's think about building exploits. So we have Windows Defender emulator with debug information. And JScript evaluation function also evaluate arguments. And how about concatenating the part of Acre signature and some input like this? In this case, if this function will be is detected as malicious, the input is R, because R and a part of Acre signature will consist a complete Acre signature. And if nothing detected, input is not R. So there is some issues in JScript engine. If statement will never be evaluated, like this one. Even the condition statement is always true, this evaluation part is not evaluated, and this statement is not detected. In this case, object accessing will help you, like this one. So just putting key and value as like a switch statement, you can build some kind of if statement. and parser stops on null byte. Uh, if the part of string contains null bytes, it will be result in syntax error. So how to deal with null bytes? So I found another feature in mpengine.dll, as well as Windows Defender. They can analyze HTML documents. Some HTML tags will be a trigger, for example, script tag, and parser will not stop on null byte. Of course, JScript can access the element because JScript engine has DOM API. If they have body tag, and like this one. So in this case, you can extract the data from inside body tag, and you can combining secrets with some part of Acre signature. Now you can have Oracle. So the payload is here. So basically, this is very naive solution, and this index and C will be iterated for 256 times. And if Windows Defender get angry if this value C is appropriate. Yeah, but yeah, it requires 250 times try for each index. So let's make them much more faster. Also, master.main function is also available, so you can do binary search like this. So in this case, the variable C is less than input. It will be detected. If it's greater, it will not detect it. Then you can do binary search. So now everything is ready. So this is a structure of fast demo application. Controllable area 1, 2 secrets. And if you put payloads like this, you can rig the secret by iterating elements. So to get Oracle, it's enough just accessing name query after querying /. If the web server responds with internal server error, it means that content will be detected. And if you can see normal response, it's not detected. So I'd like to show you demo application. So this is just demo application. And here is the POC code. This is just extracting secret parts by querying times. So POC. Okay, you can see this window. So just iterating times and times, and some Acre signature is detected, and after repetition, this part, this secret can be rigged, which is stored in secret part, which cannot be seen from user. Okay, so back to slides. So here is pros and cons about Antivirus Oracle. So for pros, attacker can use this method blindly, even attacker doesn't know about target structure because it's enough just putting part of payloads everywhere. About cons, attacker need to put two pieces of payloads, and only data between payloads will be rigged. So basically, attacker cannot rig outside of two part of data. So I tried to search any other variants. It would be great if there is a way to rig previous foreign data without two-part controlling. But I couldn't find no POC so far. Okay, so let's think about any other victims. So many applications are saving user input with sensitive data. Here is some examples. So first example is session file. Actually, I authored some challenges using this technique with session file in Tokyo Western CTF 2019. In PHP, PHP stores session data as single file. But basically, user cannot see whole content of session file. But if user can control two parts of session data, attacker can rig the data between these parts. And other victims will be log file, like the log of web server Apache Nginx IIS. Actually, I found some issues in IIS. I found that the log of IIS is detected as malicious if some malicious payloads into this. Actually, I reported to Microsoft, but it's silently fixed and no response. And another victim would be database and cache file. For database, file-based database, like a SQLite 3, we victim. So antivirus can be used to modify the file contents by using one of their feature, neutralization. Windows Defender will replace matched malicious parts by other characters after they detect it, like this. So in this case, eval acre part between script tags is regarded as malicious data, and they will be replaced by spaces for neutralization to protect user. So attacker can delete content partially. Even attacker cannot rig data, there might be something to do. So one method is wiping out evidence. Actually, attacker can delete part of log, just putting first payload before beginning attack and do malicious attempts, and final puts the second last part of payloads after attack. So if log, in this case, a log will be like this. So you can see the yellow parts. So Windows Defender will replace between script tags. It means the log file will be like this. So basically, attackers' malicious attempts completely deleted. And another method is antivirus as deniable service. So because deleting much malicious, if the matched parts over structural boundary, the structure metadata will be destroyed because it's replaced by spaces. But if two parts will not over the boundary, it will not destruct the structure, but still attacker can overwrite other areas data. So what if encryption keys are there? and they replaced by null bytes or spaces. Yeah, it should be really interesting. So how about other antiviruses? So virus total is really useful for doing such job. So I tried to search which antivirus supports JScript emulator. So you can put these two payloads, just combining a part of A character and R last character and not rated character. The upper will be detected and the under will be not be detected. After this testing, 4 antivirus passed. Sarendia Web, Microsoft's, and Nano antivirus. Actually, you can see Trend Micro's antivirus is fired, but actually this is false positive. So let's do further testing. So which antivirus support DOM API? So just putting these payloads. So after this test, only Microsoft passed. Yeah, that's why they are vulnerable to antivirus Oracle attack. So basically, Windows Defender is too smart. Okay, think about how to prevent this attack. In my Ireland opinion, no generic way to patch are there. Because this is standard behavior, it's not vulnerability. Of course, disabling auditor engine is one way. Like Chromium Access Auditor is removed in 78 version. But Microsoft would not remove the engine because it ruins Windows Defender completely. So application developers should know about this attack and not save secret with controllable data. Yeah, but remember, it's not developer's fault because and the antivirus vendor should take care about that. Okay, so conclusions. Auditor-based Oracle, like cross-site search, of course, antivirus Oracle is everywhere. And antivirus is one big example. It will be in Oracle if it has intelligent engine. So Windows Defender is too smarter than other antivirus, resulted in effective Oracle, and the more smarter engine will get more Oracles. Yeah, so far I couldn't find smarter engine than Windows Defender. So antivirus behavior will be sometimes harmful, not only data leakage, also denial of services and partially deletion, like wiping out evidence. And this is the biggest point I'd like to show you. Do not store any secrets surrounded by user input, or your application will be vulnerable to antivirus Oracle. Okay, so okay. Here's the end of my talk. Any questions are welcome.